Hi, good day. Welcome back to our class in Biochemistry Laboratory. Today, I will be demonstrating to you an activity which is activity number 6 on fats and oils. In this activity, we're going to learn what are the physical and the chemical properties exhibited by the fats and the oils. So for the first part of this activity is the comparison of the spot produced by the oil and the water. So I'm going to make a spot of the oil and compare it with the spot produced by the water. This is the spot produced by the oil, and this is the spot produced by the water. The next procedure is to take note or observe the color of the oils, their solubility towards the different solvents, and their densities. So when we talk of solubility towards the different solvents, so our observation here would be whether it is soluble or insoluble. And for the density, our observation here should be whether it is lighter or denser than the water or than the solvents. So we're going to use the coconut oil, and we have also here the olive oil. Take note of their color. This is the coconut oil. Take note of its color. This is the olive oil. I want you to take note of its color. Now for the different solubilities, we're going to use the following solvents: the water, the ethanol, the boiling ethanol, and the carbon tetrachloride. So we have here water. Let us just use about 1 drop of the coconut oil, and we will dissolve it in 1 ml of water. Okay, let's shake it. And I want you to observe what happens. Is the coconut oil soluble in water? So we will test the solubility of coconut oil in ethanol or ethyl alcohol. So we will just use 1 drop. And we will put 1 ml of the ethanol. Observe what happens. Then we're going to look at the solubility of the coconut oil in warm ethyl alcohol. So we will put a little of this ethyl alcohol, 1 ml of the ethyl alcohol. So I place here 1 ml of the ethyl alcohol into the water bath for a while. To make it warm. Okay, and into this boiled ethyl alcohol, I'm going to add the coconut oil, and I want you to observe what happens. Is it soluble? More soluble than in ordinary alcohol?
No.
I want you to observe the two. This test tube contains the coconut oil with the ethyl alcohol, which is not boiled. Well, this is the coconut oil added with the boiled ethyl alcohol. Now, which do you think is more soluble or soluble? The ordinary ethyl alcohol or the coconut oil and the boiled ethyl alcohol? Then we are going to exhibit the solubility of the coconut oil towards the chloroform. We're going to use the chloroform as a solvent this time instead of the carbon tetrachloride as written in your lab guide. Okay, then we will drop 1 drop of the coconut oil into the carbon tetrachloride. And I want you to observe. So those are the solubilities exhibited by the coconut oil towards water, the ethyl alcohol, the boiled ethyl alcohol, and the chloroform. This time, we're going to get the density or compare the density of this coconut oil with that of water. I place here about 2 ml of the water, and I will drop also about 2 ml of the coconut oil. So, what have you observed? Is the coconut oil lighter or denser than water? How do you know that it is denser, or how do you know that it is lighter? If it is denser, meaning it should be below the water. But if it is lighter, the oil should be, if it is lighter, the oil should be above the water. So you notice that the oil is above the water. The next is we are going to exhibit also the color, the solubility, and the density of the olive oil. So we're done with the coconut oil. We're going to use now the olive oil. So we will use here 1 ml of, approximately 1 ml of the water, and we're going to use this olive oil which I took it from this reagent bottle a while ago and put 1 drop. Okay, observe what happens. Is the olive oil soluble in water? Then we're going to mix the olive oil with the ethyl alcohol. So I have here the ethyl alcohol. And I'm going to drop here the olive oil. Observe what happens. And the next solvent to be used is the hot alcohol. So we're going to heat this alcohol in the water bath. So we'll heat it for some time. And we will add it with the olive oil. Observe what happens. And the last one is we're going to add the olive oil with the chloroform. This is the chloroform. And let's add 1 drop of the olive oil. Observe what happens. So those are the solubilities exhibited by the olive oil. Let's go to the density of the olive oil. Let us observe whether the olive oil is lighter or denser than water. With this olive oil, I'm going to add this sweet water. Observe what happens. Where can you find the olive oil? Is it below or above the water? Take note, the colored part is the olive oil. So it is on top or above the water. So what can you say about its density? So those are the physical properties of the oils. Let's go now to the chemical properties of oils. So we will exhibit the Acrolein test. What is a positive test for the presence of acrolein? We know that acrolein is present if the odor emitted by the mixture of the oil plus the potassium bisulfate is somewhat like a burnt fat or acrid in odor. Anyway, you will not be around here, so I will just tell you how it smells. So the next thing that we're going to do is to mix the oil with the potassium bisulfate. For the acrolein test, we are going to add potassium bisulfate to the oil. So this is our coconut oil. I'm going to get 3 drops of this coconut oil. And I'm going to add it with the potassium bisulfate. Then we're going to heat this over the flame. So this is now the mixture of the coconut oil and the potassium bisulfate. Let's heat it. If you're going to smell the odor issued out by the vapor, so you're going to fan the vapor towards your nose. And you can smell like a burnt fat. And it is a positive manifestation that the coconut oil contains the acrolein, because there is an emitted odor like that of a burnt fat. Okay, this time we are going to test the acrolein test with the glycerol. So this is a glycerol. Glycerol is, by the way, a trihydric alcohol, and it has a sweet taste. This is usually employed as a component in cosmetics. So I got this glycerol from this reagent bottle, and we're going to use 3 drops of this. And onto it, we are going to add the potassium bisulfate. So with this mixture of the glycerol plus the potassium bisulfate, we're going to heat this. And let's take note or observe how does the odor smell. So there is already the vapor that is emitted. So let's smell this vapor. How does it smell? Okay, okay. And the vapor smells like that of a burned fat. So that means the glycerol also contains acrolein. The next test that we're going to apply for fats and oils is the test for unsaturation. In here, we're going to apply the test to the coconut oil and the linseed oil. So I'll get the coconut oil. So this is the coconut oil. This is the linseed oil. We're going to place 5 drops of the coconut oil into this test tube. And we will add this with the iodine in carbon tetrachloride solution. Observe what happens. This is the coconut oil added with the iodine in carbon tetrachloride. Observe the color. Then we are going to use next the linseed oil. We're going to place 5 drops into this test tube of the linseed oil. And we're going to add the iodine in carbon tetrachloride solution. I want you to observe. This is the result of the linseed oil added with the iodine in carbon tetrachloride. Observe the color. And I want you to compare the two. This test tube, which I hold with my left hand, is containing the coconut oil with the iodine in carbon tetrachloride solution. And this test tube, which I hold with my right hand, is the linseed oil added with the iodine in carbon tetrachloride solution. Compare the two. The next test that we're going to apply to the fats and oil is to test its property of being a drying oil. So in here, we're going to use the linseed oil and we will compare it with the coconut oil. We're going to use 1 ml of the linseed oil. So we will place 1 ml to this test tube. Then to this 1 ml of the linseed oil, we're going to add this with the leathers, chemically known as the lead oxide. This is the lead oxide. its powder in form. So another test tube, we're going to put here the 1 ml of the coconut oil. And we're going to add to this the letards or the lead oxide. Remember that this is that of the linseed oil and the other one is that of the coconut oil. And we're going to warm this in the water bath for 10 minutes. Letards. After heating the mixture of the linseed oil and the lead oxide or the letards, we're going to pour this into the watch glass. Then we're going to pour also this mixture of the coconut oil and the letards or the lead oxide into the watch glass. Then compare what happens to the lead oxide when added with the linseed oil and the lead oxide or the letards when added with the coconut oil. The next test that we're going to apply to the fats and oils is the saponification or the basic hydrolysis. In here, saponification is actually the reaction between the oil and the base in making a soap. So, in saponification, this is a reaction wherein the oil is reacted with the sodium hydroxide. And this reaction is actually the underlying reaction in making a soap. There are two kinds of soap, by the way. We have the hard soap and the soft soap. For a hard soap, the base that we're going to use is the sodium hydroxide. While for a soft soap, the base that we're going to use is the potassium hydroxide. In our case today, I'm going to demonstrate to you how saponification is being processed or the making of the soap using the sodium hydroxide as the base. So as a result of this saponification process, the soap that we'll be able to make is a hard soap. So the first thing that we're going to do is we're going to mix the coconut oil or any vegetable oil with sodium hydroxide. So let us use about 30 ml of the vegetable oil or the coconut oil. Then to this 30 ml coconut oil or vegetable oil, I'm going to add this with 50 ml of the sodium hydroxide solution. So this is now the mixture of the vegetable oil or the coconut oil with the sodium hydroxide. And we're going to stir this well before we're going to place this over the Bunsen flame for heating. And we will heat this over the Bunsen flame. You notice that the mixture is getting thick, but we will continue to stir it more until the mixture is really becoming very thick. So our mixture now has already thickened, so we can put this out from the beaker. I will pour this into the molder. And I will pour the soap now into this molder. So this is now our finished product, and this is now called soap. But we have to let this settle or age for 30 to 60 days before we're going to use this as our soap. Going back to the linseed oil and the coconut oil in which we apply the drying oil test, we have observed this for 30 minutes, and after 30 minutes, I want you to observe what happens. This is that of the linseed oil, and this is that of the coconut oil. Which of the two dried readily? Or which of the two dries up readily? Those are all for today. That is the activity for fats and oils. What I would like you to do is to write all your observations, answer all the questions asked in the lab guide, and write a formal report about this activity. I want you to submit the formal report for this activity next week. This is your teacher, Professor Nisitas Ruiz of Holy Name University.